Here we go. Blog post, release post. Yeah. So blog post here explains real quick, like, hey, hello, this is what WebAssembly is. This is what components are, what WASI is, what core WASM is. And then I explain a little bit about the release process. TLDR, we're shipping every 2 months now, on the first Thursday of the month. For the remainder of the year, we're like doing 2 more releases, but it'll continue through the next year until we eventually ship WASI 03. And then hopefully we keep doing something similar for 03. We haven't really talked about that yet. And then a little explainer about @SensGates, what that is. So do you want me to explain this? Is that interesting?
Please do, because I have no idea what it is.
Okay. Yeah, I figured I could just summarize this with like, hey, we're doing releases on Cadence. So people are like, yep, sounds good.
I think so. One thing that I think this could be like a different format for the stream. It's like just going through, because you have so much knowledge in this space where like I can read it, but I'm gonna have to read it like 5 times to understand it, and so I'm not gonna read it. So, like for a lot of people, and that's probably the same for a lot of people. So like I think there's a lot of value, and like we could do a segment of the stream whenever you write a post like this, like another opportunity to kind of narrate, the post, and then you've got an audio segment with it with kind of a deeper explanation, and then I can ask my questions where, it doesn't quite make sense to me. So like this is probably a great content type for the stream, essentially.
Yeah, for sure. I mean, we can do some of that now. If you'd like to.
Feel free.
Yeah. So actually, I think that this is probably, I was really proud of this one. So I gave a talk about WebAssembly for a Rust audience last week Saturday. And I used this framing, and I'm actually wondering how this will like connect with you.
Okay.
Because like we've obviously we've been talking a lot, and you already like understand WebAssembly pretty well. But as a primer, like when we talk about core WASM is a virtual instruction format for programs to be compiled into, like x86. If I said that to you, does that make sense? Or are you like, oh, I don't really know what x86 is?
I know it's so in my brain, it's lower level than I have ever coded it. So like I understand kind of what it's meaning, but I don't have any context of like what that would look like. But I do now, because of our previous conversations, I understand what it means. I just have a lot of context for it, but it makes sense.
Okay. I wasn't sure, and you're saying like, well, only because we've like talked about this before, does it make sense now?
So who's your audience with it? So that was primarily because like I've been over like infrastructure scripting land, and goes the lowest level I've gone. So like that's even lower on the instruction set, towards the hardware. So it's probably more my background where there's a knowledge gap. So I would assume your audience is probably going to be a little bit more familiar with those coding formats, maybe.
I don't know.
Okay, well then I'm a good guinea pig.
Yeah, exactly. So because the audience is like programmers in general, which includes people from JavaScript, from people who are like more into ops or scripting, but also Rust programmers or other like Go programmers, low level things. It's so broad that's kind of like hard to explain. Like WebAssembly is weird because it's like a low level technology in a way, but it enables high level things. And so we want to talk about the high level things, but then we use low level terminology, and I was like, I don't know how to like.
Here's the 2 phrases where I get stuck. Where I vaguely understand what it is. So instruction format. So like right there, if I were to read that one sentence, core WASM is a virtual instruction format for programs to be compiled into, and then think x86 and 64. So like my first question is like, what's an instruction format? And then compiled into. Does that mean compiled to? Like that would be, is that synonymous with that?
Yep.
So I would just maybe say compiled to, because into makes me think that it needs to go into something else.
Okay. Yep.
And that's more like the writing editor part of my background. And then but then the think x86-64 has a little bit more helpful because it gives more context to it. But my biggest it's like, okay, well, what exactly is an instruction format?
Yeah. I'm guessing a link to Wikipedia would be very helpful here.
Yeah, that would be the first thing I do is like instruction format or content.
Yep.
Oh, okay.
Yeah. Absolutely. No, that's a great shout. And into was like, I wasn't sure if it was like to or into, and like in Rust, when you take a thing and you convert it into another, it's into. So I was like,
okay.
oh, probably into, but you're like, but in English, I'm like, oh, okay. we're not writing Rust here, we're writing English.
Yeah, because to, and because then it becomes a thing, because you're going to put it, to something.
So then the second one is, maybe I'll patch it like after stream, where I'll like add a little link where it's like,
I can still understand it. It would just be English clarity.
And maybe if I say x86-64 assembly would be helpful, because then people are like, that's the thing. Instructions are like assembly, and then like we link, and then that's clear. Okay, so WebAssembly components are a container format and type system that wrap the core WASM instructions into typed hermetic binaries and libraries. Does that check out?
Everything, the hermetic binaries, I don't know what that is.
Okay. It's maybe a little bit of a buzzword. Like people have been using it to like describe things, and I like it, but it's also, I realize it's a bit of a buzzword. But hermetic means it's like hermetically sealed or without external dependencies. You oftentimes hear it for hermetic build systems, which are build systems that are self-contained. And then if you want to spread them out, for example, you can put them on multiple machines and get them to build different parts because they're self-contained. So that makes it easier to move around or to create, for example, reproducible builds, which you need for validation of your artifacts, that kind of stuff.
Gotcha.
Because non-hermetic build systems have this problem where it's like, it's hard to reproduce the build. Like, we signed it, someone wants to check it, you can't check it because it's non-deterministic. Or there's
go ahead.
Or there are like random system dependencies that like sort of vary or like have timestamps in the thing, and it just makes it difficult. Go ahead.
Okay, so more self-contained is like, that's if I were to translate.
Yeah. Self-contained is a good way of saying it.
Okay. And then, so like, what's the context for container format? Because my mind immediately jumps to like OCI container formats, but I assume that it's meaning a little bit different.
Yeah. So a container format, like in the general sense, is like
from a data structure perspective.
Yeah.
Okay.
I think that's right to say. For example, video codecs, they have the actual encoding, and then they have, for example, .mkv is the container for that, or .mp4. And you can have different like encodings within, but the container, the shape of it around it is different.
Gotcha.
Like with HTTP, you have HTTP as a protocol you could think of as a container for example, JSON or XML or any other like structure within, but it has metadata in a specific way, and then the content may like differ.
What really helped me understand it, though, was the next little bit, which is that wrap core WASM instructions into typed. So like that WIT definition, that actually helped quite. That brought a lot of clarity to it for me.
Okay, I'm glad. That's good. And the final bit is WASI is a reserved namespace for a collection of standardized WASM component interfaces. Kind of like POSIX, if you like, on Linux and macOS, they share some things, and that's the POSIX standard. It's kind of the same thing, where it's just header files, it's just interfaces, but they are standardized.
That one made complete sense to me.
Yes. Okay. I'm going to give this section hopefully a good enough for people who are like, okay, what is this stuff? Oh, okay, I kind of see. Okay, great. Now we can keep reading.
Maybe we can move the live streams to like right before you publish, and we'll just do a edit pass.
I'll
Let's see if Josh understands.
I might just like start tagging you in these things. Like it'll be helpful.
Yeah, please do. Yeah, I can definitely help.
Yes. So already talked a little bit about this, but like we're releasing every 2 months. It took some effort. It took us 5 years to go from 0.1 to 0.2, and it took us 6 months to go from 0.2 to 0.2.1. And now every 2 months after that. Yeah.
That's a good connect bullet. Find that rate of improvement and
yeah. Oh, yeah. For people on stream, we're like, what's a connect? It's like, that's our internal Microsoft review. Yeah, exactly. I might do that. That's a good idea. Okay. So adopting the @since gate notation in WIT. That's one of the main features. So the fact that we're shipping at all, that took so much effort and most of the time. But like the concrete like thing that we're shipping, the actual like change, it's like a whole slew of like doc changes. The last 6 months of like copy edits and all that stuff. But we're making use of one new feature, which is the @since gate notation. So in WASI 02, interfaces look like this, where it's just like, hey, the name of the interface, some functions have return types, and then the host implements it. The guest toolchain, so the language like targets it and says, hey, I'd like to call this, and that just works. But then here in 021 is we are now annotating them and describing when they were introduced. So all of these interfaces landed in 02.0. All documents, all WIT documents are always like versioned. So we know what version this thing is itself. We know what version these interfaces were added in. And then they'll be useful because as we upgrade things, we can now know like, oh, I'm using this version or I'm targeting API from that version. And maybe there's like mismatches or it helps sort of track these things. And importantly, also, we have made mistakes in our interfaces. We know we have, but we can't make breaking changes until the next until 03. So what we want to do is we want to like add we have a new notation that we're not yet using called @deprecated that allows us to be like, hey, this actually don't use this API. Please actually go and use this.
It works for now, but don't use it, please.
Yeah, exactly.
Okay.
We're not going to break you, and everyone should implement this. But yes, please stop using it. And then once the breaking changes happen, we'll likely like remove all the deprecated and just use the new ones.
But that random question: is there an LSP for WebAssembly?
For WIT, there is. So for the interface types, there is. Yeah.
Okay.
And if you're
just random thought, I was just curious.
Oh yeah. I don't believe we've added support for the gate notation yet, and we should. Someone should. Because when you asked the question, I was like, because there's a WebAssembly text format, .wat, and that's like a Lisp-like notation. For a second, I wasn't sure if you meant like the types or the instruction format as like Lisp, but it's like it's the former. Yeah. There is. Anyway, that's roughly what this part of the post says, which I hope makes sense.
It makes total sense to be able to define the versions of it. So really, what version of WebAssembly that these came from? So like this whole package here is from 021, but this particular interface was introduced in 020.
Exactly.
Okay. Yeah, makes total sense.
And then, at some point we'll be adding new interfaces and I'll be like, hey, this was added 022. And then you can, for example, in your toolchain be like, okay, we're not yet going to compile for that because no platform supports it. But then at some point platforms say, hey, I support it. And then you know which APIs are part of it, just like by reading the actual like interfaces.
So this, to kind of chain this back and link it up to the previous one, the random is inside the WASI, the reserved namespace.
Mm-hmm. Right? Exactly.
Okay.
Yeah.
To then export functionality from, is it like the core WASM? Am I using the right terms there?
To export functionality. I don't know what you're trying to say.
So if you go up to, let's see here.
This here?
Yeah, that first. So core WASM.
Yes.
This WASI creates, so that get random is now added to the namespace that is the collection standard for WASM. So does that now become part of core WASM?
So
like how is core WASM and WASI linked?
are you familiar with header files in C
No.
at all? Okay. Interfaces in Go.
Yes.
Yes. So you can think of WASM components as Go interfaces.
Okay.
And occasionally also an implementation of a Go interface. So there's the abstract interface, and then there's someone's implemented that interface. So,
okay.
And
that's what WASI is.
That is what WASM components are.
WASM
they
components.
are,
okay.
Yeah. You can think of WASI as the Go standard library, which has.
Okay, let's bring it back now. Like what we were creating, that would be going into the.
Exactly.
As an interface. Okay, well, the standard library, because then we would import that in and be able to use it like we would, like the syscall one, like that actually wraps libc. Okay.
Exactly. And then
that's good. Yeah, keep going.
And then core WASM is just like the function bodies, where if you have like a snippet of Go code that says like, hey, I'm opening a file and I'm doing some stuff on it, right? By itself, that's just commands, that's just instructions. It's only once you add it to an implementation, you stick it inside of a function or inside of an implementation of an interface, that you know what you're like doing with it, and you can invoke it and call it. But we can write pseudo Go and like just show the commands and instructions, but they don't do anything because it has to like have an interface around it. So very abstractly, it's a difference between like instructions and like typed interfaces that you can invoke. Components are those typed interfaces. Otherwise, you just have the instructions.
Go a little, like double click a little bit more into the instruction for the core WASM.
Yes.
So I get I understand that the components give you the type, kind of like the type definitions and all that good stuff. And then like the WASI would be kind of like a standard package that you could import that's kind of fine tuned around that. So then the core WASM is, I'm just a little fuzzy on that. Can you repeat that a little bit or dive a little bit deeper into the core WASM, like how it relates to the other two and then its purpose? See if I can rock it.
So in programming languages, you typically separate two things. So I'm going a little abstract, but maybe it'll make more sense.
Okay.
You have the type system part, which is the abstract like interfaces and whatnot. And then you have operational semantics, which is effectively function bodies.
Okay, right? So like func and then whatever the value receiver and then inside the curly brace that you're talking about, that section?
Whatever's inside of the curly braces are what we, that is subject to operational semantics. That is the function body. Those are the instructions, the sequence of things we're executing. The function signature itself and all that stuff around that, the return type, all that stuff, that is part of the type signature, part of the type system. Core WASM describes when we compile the stuff, like what the function body should compile into.
Translating into the binary format, all the instruction sets.
Yeah. So very simple function add that takes an integer and another integer in the signature. It says A integer, B integer, and then it says we're going to return another integer, right? So A and B, and then inside the body, it will be like A plus B, and then we return the result. Simple add function, the simplest add function in the world, right? Take two arguments.
All that inside the function block is like that's the core WASM doing.
Yeah. Exactly. So A plus B compiles to instructions, which is core WASM. The signature, we take A and we take B and we return another integer. That is part of the type system. You would express that in components.
Okay, and then if you needed to pull it, like say I wanted to use get random in there, that would be WASI right? It's a package being pulled in, and I would use that inside the instruction. And then, okay, that is a powerful analogy. Right there, the programming language analogy. Like, you should keep that in your pocket for some storytelling.
Yeah. It's helpful for me too, because I'm like, oh, how do I explain this? And it's like, no, it's good.
No, that's super good at the high level, because then it gives you avenues to dive further into it. Like, well, how does core WASM work? Like, how did it figure out, the instructions and stuff like that? Yeah, that's good. That's good.
Okay,
we can leave it at that. Okay. That was fantastic analogy.
Okay, I'm glad it clicked. Like, because like we are targeting like all programmers with this, like operators, implementers, low level languages, high level languages, and we're trying to be like, okay, how do we explain this stuff? Because it's like, here's the thing, everyone can use it, and it's like,
well, that was actually a tricky part for me getting into this space. What mental models do I use? And so, like, you just a really big aha moment. Not to understand it with the programming language analogy, like break down the language itself and what these things mean. Because I kept trying to overlay, like, oh, well, maybe it's similar to containers because it does this, but then I'm like, all these mental models just aren't overlaying properly. Like in some of our earlier conversations, like, does that mean like this in OCI? And we're like, well, no, it kind of, so
right.
Fantastic.
I'm glad. It's because WASI, WebAssembly, components, all that stuff, it's like, it's not perfect. It does some things very differently from the way we do computing today, using like our operating systems and binaries and all the libraries and system dependencies, containers, etc. What we're trying to do is like make sure that we target the like analogous workflows by and large, to the point that people understand and they're like, oh, I can just use it this way. And that is, from that point, we want to use as a jump it, like a springboard to like show, okay, you're on board with us now. Great. Now let me show you some really cool stuff. And that's when we are like, component composition, like, oh, did you know it's like sandbox by default? Okay, great. We're going to like strip away the entire operating system and like virtualize everything. And it's like, what is going on? And it's like, oh, that's so cool, But first we have to like get to that, bring people along
like,
for that
how do I understand? How do I use it? Basically, what the biggest first hurdle is getting people to see how they could use it.
Yes. Yeah. Exactly. Remember when containers first came out and everyone was like, oh yeah, they're like lightweight VMs. Yeah, we're kind of doing the same thing here where it's like, oh yeah, they're like lightweight containers.
Yeah. Ish. Yeah, but then the interesting part is it doesn't quite, the containers, they were closer to the infrastructure, where like now you're like, well, what if it really didn't exist? What if you really didn't need to care about all those different facets of the infrastructure?
Yes.
So then when you do that, now I understand why it's more closely related to a language, like a programming language, versus the infrastructure component, because it really doesn't exist.
Exactly.
Because now you're talking about memory sectors. It's like, oh, well, okay. Where's my operating system mental model? It's not working out here.
Matt Butcher from Fermion like has a co-creator of Helm, I believe, if I'm not mistaken.
Okay, sweet. I didn't know that.
Yeah. It was like, yeah, what are his like credentials? He's like, oh yeah, co-create Helm. He's like all into like components now and like WebAssembly, and he has like a company that like doing specifically that. But the analogy he uses, I might be wrong. Please do fact check me.
Sure.
But the analogy he uses is like, this is like third wave cloud computing, where first we had VMs, then we went to containers, and now components. He doesn't call them that. He says cloud, or like cloud native binaries. I think the idea of like, yeah, we are just producing binaries is a really good one, because it's mostly accurate. Because like components are just, or sorry, containers. Nobody wants to run a container. We just have to run containers. Ideally, we would just have the program, and that's what we'd run. But you can't just do that. So we need to like have stuff around that. But now we get to strip it away, and it's like, no, it's truly just the binary that you ship around.
Yeah, I need to watch some more of this stuff. I'm really interested in, what was the book that Steve recommended me? He was talking about how like how it could revolutionize serverless. Because that in theory, serverless does the same. It's supposed to give you the same thing, right? But there's just too many limitations running in a container, like running in a VM behind the scenes, that it's not truly serverless. You know, there's always a server somewhere. But with this, it could be, and how much more efficient it would be to run in WebAssembly. I'll try to find that book and bring it back to the stream because it's really interesting.
Yeah, that would be cool.
From a financial perspective, you know, like cost and complexity, but
yeah, for sure. Because like I know we should be able to like get down to like 1 millisecond boot times for like, or we have this working, single millisecond boot times for like WebAssembly components in like full VM slices. We can get to like microseconds if you just use WASM time. But yeah, compare that to like traditional VMs or even like really fast ones, like Firecracker, I believe, is like 125. That's like 100x like speed, like performance improvement.
Yeah, and like what percent of VMs are actually running that though? They're mostly
yeah, exactly.
Minute, we're talking minute boot up.
Oh yeah. And that like it really changes like the way you can like you don't have to keep stuff idling is really interesting. Or like scaling up if it's instant.
Ooh, burst would be interesting.
Uh-huh.
How do you handle that on the orchestration side? That's where my mind goes.
Oh yeah.
But I suppose that's where Hyperlight comes in.
Mm-hmm. Yeah. It's like once you have like these super lightweight binaries that don't need the full like infrastructure around it, you're like, okay, let's put it on Kubernetes. And then suddenly you're like, oh, wait, hold on. There's real limits to what Kubernetes can handle because it assumes maybe hundreds of like, containers, not hundreds of thousands or something,
It's interesting to be able to break the orchestration scaling of Kubernetes though, because that was like its whole thing.
Mm-hmm. It also assumes some amount of longevity. Like burst means it's up for minutes,
hours,
at a minimum.
Days, like it's Black Friday,
kind
of thing.
But here you could spin something up in under a millisecond or quicker.
Imagine the cost savings if your burst was like in real time.
Yeah. Well, we've seen some of this with Zeiss, right? And they were able to save 60% of their compute cost on the first version.
Imagine like Netflix or something like that. Like their demand is so random.
Oh yeah.
Like I'm not saying they could, but just like a service like that has such fluctuation in demand, or retail, really.
Oh yeah, 100%.
There might be a sale that's hard. It's really hard to burst like that, unless it's a Black Friday, like a really consistent for a particular. But then there's so much waste at like maybe 2 a.m. In the US, like all your regions that are US 2 a.m., like, but you're going to keep it online anyway for the next 40 hours because the sale doesn't until Monday. What's that bill of your scaled up instance?
Oh yeah.
Yeah. Okay. That's cool. That's really cool.
Yeah. No, I definitely think so. There's so many things to that too, where it's like once your boot times are so quick, you may need less beefy machines. So you can like put it on the edge too. And so, like once you put it on the edge, your latency becomes better, and that can like have other like benefits. I don't know. There's so much stuff there. But yeah.
Interesting. Oh, cool. We got it. Oh, so we got some OCI.
Yes.
Familiar territory.
Yeah. So it's just a little notice that, we are now publishing things as OCI. It's mostly like what I showed already here, with all of these interfaces are now being published. They've got their, did we not stick a license on this? Oh, no, we did. Here, look, a little license there, little repo, all that stuff.
We need a note to self. We need some better production for our streams, because we should have some clips for when we were walking through publishing this, because for people that are curious, like going through Whackage, and you added the annotation thing, and what are the commands? What's it look like? Getting it up there. We were able to push some components ourselves that we wrote, the web clip that we put up there.
Yes.
So
yeah, exactly. Yeah, for sure.
It worked on our machines as well, with a little bit of struggle, but we got it.
we've definitely had this tooling working on at least 3 computers.
Yeah,
it's very promising.
Yeah, just not WSL yet. That's because
yeah, exactly. But yeah, that last little bit of the release post is just explaining like what OCI is, the fact that we have it on there. If people are like interested in this, how to get involved. Hopefully for the next release, we may have better integration with tooling. So Car Component is currently in the works of landing native tooling on the what is it, on the specification side. I'm trying to make sure that we have a WebAssembly native way of encoding the information. So your actual WebAssembly binary, for example, would include like, hey, I am this license. And then Whackage can just read the data out of the component, or whatever the publishing tool is, read the data out of the component and use that in order to publish it, rather than like needing to read cargo TOML and directly go through it. You just go through the component and all the shared like things like share it, and making all of this standard and making it part of the flows by default, I think will be really good. And yeah, this is the first step in going there. So it's pretty good.
Yeah, getting the artifacts out there is good. Solid stuff.
Yes.
Got a specification now. So it's all good.
Exactly.
Sweet. There's a lot of good stuff in here. This is helpful for me.
I'm glad. First release, so the notes are like not like, oh, check out all these cool APIs, but more like, we've shipped a process. We're including some new features that have been rolled out, and more releases soon.
Well, I love the tidbits diving into it more, because there isn't a lot of great literature right now just to understand the technology.
Yes.
So like these little tidbits are super helpful. And having you go through it and ask questions was even more helpful for me.
I'm glad. Yeah, we should. It's so hard to like frame things, because like when you're in the neck of it, you're like, oh my god, here's like system problems and we can solve it through this technical solution here. And then you like emerge with like, okay, we have it, the perfect solution. And people ask like, okay, what's better? And you're like, it's better. You gotta explain it, but especially like in terms that other people can understand, because they're over there like using their current things and like, why is this useful? How does it help them solve problems? Like navigating that is so tricky. And we're trying. So thank you.
We've touched on it even on the stream, imagine being able to scale like real-time bursting.
Yes. Yeah. It's also like not stuff that's like, oh, in the far future, we may be able to like, selling vaporware. I was like, no, we've done this for actual like clients. They have it in production. We have the numbers back. What we're now trying to do is like get the user experience smooth enough that everyone could do it.
You get the user experience closer to like what Docker did, where it's like Docker build, run, kind of thing. Like that would be sweet. It's different because it's more of a programming language. So if you can just document like that particular process, it's not going to be as simple. But I think we're getting there.
We are, definitely.